And with that, I guess we're slowly going to start with Christoph Bublitz. He's a researcher at the University of Hamburg, focusing a lot on the interaction between brain, computers, AI, and all the fancy stuff. Maybe he's going to answer whether we are all cyborgs or not, but I think his focus is more like on the ethical and philosophical question, how to deal with whether we are all cyborgs. He's a legal scholar. He's a principal investigator on like several international research teams. He's a lot focused on the hybrid mind, whatever that means, but I guess he's going to explain that to us. So his talk, philosophical, ethical, and legal aspects of the brain-computer interfaces. Christoph Bublitz.
Yes, thank you very much. Welcome. So at the end of this conference, I would like to take you on a little journey into the future and the future of human-computer interaction, the merging of us humans with the machines through technology which is called a brain-computer interface. And on this journey into the future, I would like to make 4 stops. I would like to bring you up to speed about what is a BCI, a brain-computer interface. So I will say BCI, I mean brain-computer interface. So what is it? What is it not? What might be special about it? There are several interesting philosophical questions around it. Then what could go wrong with this kind of technology? And what may we want to do about it? So I want to talk a little bit about international discussions at the moment about ethical and legal questions. All right, and before we start, I do not have any personal conflicts of interest. Okay, let's start. So, what is a BCI? So I think a good way to approach this is to ask, how do we use a computer? How do you use a computer? And the answer is, we use computers through our bodies. So we type, we move the cursor on the mouse, we speak. But all the outputs from us and the inputs into the computer are mediated by our physical existence, by our bodies. And the same is true for the other way around. All the information that computers send to us are taken up by our senses, like we listen to something, we look at screens all the time, all these kind of things. So input and output into the computer and into us is mediated via our bodies. And these 2 ways, these channels, these input and output channels, are severely limited. So you may know, sometimes you think faster than you can type, and immediately there's a confusion, thinking too fast, so it doesn't work. Also, the kind of inputs that we are able to process is quite limited. You all will experience at day 4 of this highly interesting conference, to some degree, that input channel is a little bit exhausted, right? So roughly speaking, the bandwidth is a little bit low, both in terms of input and on output of the computer-human interaction. So then, of course, an old idea was to say, okay, let's bypass all the body. Let's just bring the computer much more closely to the central nervous system, to the brain. And this is an idea that has been in the literature already in the 70s. And the question is now, how are we going to do this? Okay, so one way of doing this, there are many ways, but one way of doing this is to use the electric signals of our brain. So our brain is a biophysical organ. It has many different chemical features, but it also has electric signals. So our thinking runs on electricity. So the idea is, of course, let's try to interface with that electricity. And the device to record electricity from the brain, that is already very old, that has been developed exactly 100 years ago in Germany by a guy called Hans Berger. That is the EEG, and he found out so you can put electrodes on the scalp and they can measure electricity of the brain. And this by now is a very standard thing, and the EEG is a standard medical tool. You have these EEG caps. This is nothing new or nothing spectacular. However, the signals on the surface of the scalp are not very good. They are very noisy. The spatial resolution is not very good. We can't do that much with that signals. So the idea is, let's then just go into the brain. Let's go under the scalp. And let us implant some electrodes in the brain. And this is also an old idea. The first thing of this thing has been done already in the 90s. You see one of these, a typical device on the bottom. That's like 100 electrodes, I think. They can be implanted beneath the skull. And yeah, you may want to ask, why would anyone want to do this? Well, if I can't type fast enough, that's of course a luxury problem, perhaps. But many people, have problems using their bodies, are paralyzed. So the whole idea was to start with people who have trouble using their body to control a computer. And here on your right, you see Ian Burkhardt. He's one of the pioneers. I had the privilege to meet him earlier this year. He was one of the first who got this type of implant. He had an accident, so he was paralyzed. And you see the cables coming out of his brain here on top, and the cables then go to a computer. And that computer then can control whatever kind of technology you want. So you can put on a prosthetic arm, that's what is done a lot of the times. Or people that are locked in, they can try to communicate with a speller device. And in this case, they actually managed that the computer then controls the rest of his arm that was still functional, so to say. So it was basically the computer controlling other parts of his body. Okay, so this is what this technology is used mostly at the moment for rehabilitation purposes for people who have lost the ability to move or to communicate. So much for that one direction, taking signals from the brain and translating them into some kind of output. Then there's also the other direction. We can also use electric signals as inputs into the brain. And this is often, well, the former, what I just told you, is often called reading the brain. This is called writing into the brain. So the idea is to take electricity and intervene in particular brain areas. Now, the important part to note is when people here in the computer sciences speak about reading and writing, they mean something different. So this is not something like putting code into the brain. We cannot do this yet. So neuroscience knows a lot about how the brain works, but it has not yet cracked the code, so to speak. It doesn't understand the software language of the brain. This is something we have not yet figured out. So what we mean with writing into the brain in this context is much more crude. It's basically giving little electric impulses to specific areas of the brain, and through trial and error, neuroscience has found out what kind of mental effects this may have. And to give you one example, this is really state of the art. This is like current technology, this kind of stuff that is tested. Here is one device. I'll just briefly explain this, that combines these two elements. And this is called a closed-loop brain-computer interface, and it is used to treat depression in severe cases. So the idea is you have the electrodes that read out something from the brain that is related to the mood of the person, the emotionality. And if the emotionality drops too low, we have a stimulator that stimulates and pushes the mood up a little bit again. So we would have an electric, kind of like regulatory system for affective disorders. This is something that is currently tested. This has been done in humans, but this is still not like medical standard practice. This is cutting-edge research. But it is, in a sense, interesting, especially if you consider the fact that the regulation, like how much stimulation should we be giving when, is done by a computer, of course. And today, this is, of course, run by machine learning algorithms. Actually, machine learning algorithms are one of the reasons why this whole field has progressed in recent years quite a lot, because the brain signal is very complex, there's a lot of noise, So machine learning actually enables much of these technologies. So in this case, if you want to take a big picture, and this is a little bit simplified, but in order that you get the idea, you read out brain signals, you have a machine learning algorithm that then sees whether it should change the emotionality a little bit, and that is then a closed loop, so it works without input of the person. In that kind of a system, you could say that at least the effectivity of the person is partly regulated by such an AI BCI system. Okay, so much. Now you have a basic understanding of what this is all about. But all the examples I've been giving you so far, they are all about medical stuff. And of course, the idea is, why should we only use this for medical stuff? Let's also do it for non-medical stuff. I will speak about consumer purposes, but there's a whole broad range of things you can do. The military can do something with it, you can do wellness, you can do gaming, many kinds of applications that are non-medical. And of course, companies are trying to do this. This is a Facebook presentation 5 years ago. So they wanted to say, let's get rid of the keyboard, we will do all the Facebook stuff with a brain-computer interface, and they launched this, this product. However, it didn't really work, so this has already been stopped again, because they also came to the problem that using electrodes from the outside of the skull, from the scalp, just doesn't really work. So even though the technology is around, they haven't really found a really good way of making this work, and they haven't really found a killer application, so to speak, for this. So, and they also, everybody was saying, so if we can't get the signal from the scalp, nobody would want to have it implanted for these kind of things, just to get rid of the keyboard or playing games. Who would want to have an implant for that? Nobody, so we quit this. However, of course, as these kind of technology stories always go, there are new startup companies now coming with the explicit aim of doing this, of implanting these kind of technologies for non-medical purposes. And here's one company that I will take as an example because it's particularly ambitious and it's also particularly open about their aim. So their mission is they want to create a generalized brain interface to restore autonomy now to patients, those with unmet medical needs. So this first we do this with patients, and then when we know how it works, then we will give this to everybody and we will unlock human potential tomorrow. Yeah? So we will unlock everything that our brains can do. So this is their mission, and they actually have, yeah, and the idea, the business idea is something like, first we do this with humans and then with patients, and then normal, ordinary people that have no medical problems, they will see how good this works. And then they will want to have this as well. And so, for instance, in gaming, it's very important how fast you can move kind of the cursor kind of thing. So if the people, the patients that get this now who are paralyzed, if they are really good and if they can, for instance, game much faster than the ordinary gamer who still has to use their body, then the people will want this. This is one of their open interviews. This is kind of like one of their business models. Okay, and they have actually made some nice inventions. What you see here is the chip that they invented. They call it the link. So that is the link between you and your brain and the computer world. And it's very small, and it has these very fine threads. So they are like a tenth of a hair. And on this thing are 1,000 electrodes. They're so small you can't see them with the eye, but one of these things has 1,000 electrodes, and it's quite a sophisticated thing, the link. And yeah, and they have implanted this. Meet Pager. He is a monkey, as you see, and he is playing Pong. I thought this is what some of you might appreciate it. You will see him now playing Pong only with his thoughts. So what he's doing with his hands, he's just getting sugar out of this tube as a reward, but he's moving the cursors left and right by thinking about moving them left and right, and he has 2 of these link and 1 chips implanted on the left and right side of his brain. So this went around in the media like a couple of years ago, and they have since then made more progress. Also, I should have said this earlier, implanting something into the brain is not quite an easy thing. So this is quite a complex medical procedure. You need neurosurgeons, which are like a rare species in general. And it can have, there's inflammation, there's many problems. So if you want to roll this out outside of a highly controlled clinical system, you need to do something about it. It's very unlikely that brain surgeons will implant these kind of things on a wider scale. So they come up with a new idea to implant these kind of things. And you see on the top here how they think this works. So you basically cut out a little piece of the skull, and then you put in the chip, and the chip basically replaces the skull, and then the skin can grow over it again, so you don't see it from the outside. So with the pager, the monkey that you've just seen, you don't see that there's no bulb or anything on his head. And the data is transmitted wirelessly, and of course the device is also charged inductively, so there's no cables anymore, as you've seen in the beginning. So from the outside you wouldn't see this. And now also they needed a way to implement this, and now they took inspiration from a very old technology, the sewing machine. And so they built basically a robot that can sew in these threads like a sewing machine in your brain. That is their innovation. The surgical robot that basically modulates this idea. And it's actually, I can actually show you a little video. This is you will now see the needle implanting these threads into the brain. This is not a real brain. This is just a model of a brain. So there's no blood. Don't worry. But this is how it works. You see the needle, and it then injects these kind of threads. It's actually quite fast. They can get 1,000 electrodes into the brain in roughly half an hour. So that's quite a lot. And I mean, you still need, the surrounding surgery. But this is now really a way to automate all of this. And even though this looks very easy, I should say this is still a very complex surgery. So for instance, you take a 3D model of the brain before with brain scans, and you map out all the arteries and the blood vessels so that this thing doesn't stitch through this. So this is still, it's not as easy as it might seem, but it's definitely a new invention. Okay, so if you think this is a little bit scary, having this sewing machine putting 1,000 electrodes into the brain, yes, I think this is a little bit scary perhaps. And you will be very pleased to hear who is behind all of this, so your worries will disappear. And so Elon Musk funded this company in 2016. And it's not only him financing it, he has at least $500 million of venture capital. And and he came up with this. I don't know if he came up with this idea, but this is his company that is doing all these things. And you don't need to worry, because when you ask him, why are you doing this? And he, of course, has very good and benign motives. It is, of course, to save humanity, because the AI will come, and then we humans are thinking so slow, and then the AI will take over. So if we want to keep up with the AI, we better, get ourselves updated in a sense. And this is the way to do it. So it's all in your interest. Now, this idea of saving the world through technology is, of course, a very common theme in this techno-libertarian Silicon Valley world, and that is behind here as well. But the thing is a little bit more ambivalent. Let me also show you what Neuralink describes itself of what they are doing. They are saying about themselves, we are promoting, we are working for digital freedom. And I mean, this is something, this Congress is perhaps, epitomizes the idea of struggle for digital freedom. And it's quite interesting to see that Neuralink is basically working on the same issue. So, it is, of course, different understandings of freedom. What they are talking about is the freedom to use digital technologies. But the freedom to use this and empower people to use this is, at least at some deeper level, of course, linked to the freedom from, let's say, governmental surveillance that will prevent people from using this. So there is some overlapping concern here, I think, and this shows how ambivalent all these kind of things are. Okay, so speaking of this, it's a little bit hard to speak in a short time and to show you the craziness and the spectacular stuff that is going on without falling into the neuro-hype thing. So, as with all emerging technologies, there is a little bit of hype around this, and I do want to flag this explicitly. So there is a hype cycle, and some people say we are, with the BCI technology, perhaps now at the peak of expectations, and these expectations are inflated. And what might happen soon is that we will fall down into the valley of disillusionment. So this is something that could be happening, and it would not be atypical if this happened. Also, I should be saying, these are not renegade scientists. This is strictly regulated clinical research in the US under the FDA. The FDA, Neuralink had to apply it several times. The FDA was always rejecting these kind of trials, so this is strictly overseen. And also, this is still working only on the upper level, or surface level of the brain. The really interesting mental functions often lie much deeper, which complicates the whole thing even more. Also, I would not want you to take home, oh, BCI, that's this Elon Musk kind of sci-fi stuff. No, that's not the case. So Elon Musk, they are the new kids on the block. There's an established research thing. Many people in the world work through this, and they are committed to, basic science or helping people with disabilities. This is just the new disruptive business model that comes on top, and many in the field see this very critically. However, most would probably say this is the first time now that there is a company that has the financial power and the clear agenda and the technical innovation kind of background to really make this happening, that we will implant these kind of things in people outside of the medical context. Okay, so this was the first part. Now I would like to come a little bit to the problems and the philosophical aspect, and as the future is approaching fast, I have to rush a little bit. My time is running out, but there are certain, let's go back one slide. So there are certain philosophical questions here. So one of the questions, or a class of questions, usually concerns the relation of the person that has such a BCI to the world. So let's take the affectivity example. Suppose somehow parts of your emotionality are regulated by this kind of AI device, then it might change how you resonate with the world. So let's say you are happy or you are sad. You may wonder, am I happy because something happened just to me, or am I perhaps happy because that stimulator was a little bit stimulating too much? So these kind of questions will immediately change how you perceive the world and how you resonate with the world. Let's put it like this. And other kinds of philosophical questions concern the relation of the person to that very device. And there's one aspect, one philosophical argument I would just like to briefly show you, because it relates perhaps to the kind of things many of you are doing here. And that is the philosophical question whether such a BCI may become part of the person. Now, and that is, of course, also a philosophical question that you can try to answer from many different directions, but let me try to work perhaps with an analogy. So, with ordinary prosthetics and implants in many cultures and also in many legal systems, it is kind of accepted that at some point when something becomes firmly implanted inside the body, and it's also kind of like functionally integrated with the working of the organisms, then it also becomes part of the person, and we treat it like this. So, for instance, your dental implant is part of you just as your other teeth are. Or for instance, we bury people with their pacemakers. So this is kind of like the reasoning. Let us suppose, for the sake of argument, that this is true. Now, what would this mean for these implants? This would mean that they also become part of the person, and they would then cease to be independent things. They would become part of you just like your arm is, or some other organ. Now, and if that is the case, the novel, interesting question is, now what does this do to the software, to the machine learning algorithms that run all these kind of things? And I would be saying, well, then they become part of you as well. You can't really separate them. And this would then lead to a very interesting point, a conceptual point. So if this were the case, then this would create the most intimate relationship that humans could have to an AI, to a machine learning algorithm. It would literally become part of you. So it's not something external anymore. So I'm not saying this is the kind of AI that will influence our lives the most. All the other kind of AIs that will come around us may do much more, but it's conceptually interesting to see at this point really the AI becomes part of the person in a literal sense, even under very conservative kind of assumption of what it means for something to be part of the person. So that's philosophically interesting, but it also has legal implications. So there is an old legal principle that comes from the abolition of slavery, and it says, there shall not be property in body parts. So this is why you cannot, nobody can own your arm or so, at least as long as it's detached to your body. So if this is the case, then the manufacturers would lose their property in this implant. That follows, this is already the case with other implants. But now the interesting part is what happens with the software that's running on this. And I would argue that then, because the software is part of you, if you would now edit the software, let's say we hack the software, you do something to the software that you are usually not allowed to do because copyright prohibits this would then be something like you edit yourself, like you're altering your own code. And if that is the case, I think the copyright on those kind of devices must vanish. So from this follows the liberty to access this code, even if it would contravene copyright laws. I think this is a quite interesting argument. And this is, of course, I should be saying this is just my legal view. I was looking for case law. I haven't found any case law. If any one of you knows of any cases anywhere in the world that deal with this kind of scenario, I'm very interested. Please contact me. And also, if any one of you happens to be hacking medical implants, I would also really like to talk to you, so perhaps you can hit me up. Okay, so much for the philosophical part. Time is running. Let's go to the part. So, what could possibly go wrong with such kind of a technology? Okay, I don't even want to mention device security here in this audience. But perhaps we can say more generally, so if these technology connects us much closer, as these devices connect us much closer to the technology, then all the problems that we have with digital technologies anyway, unhealthy user behavior, these kind of things will, of course, probably amplify. And this will be especially true for all the mental effects, the negative mental effects. Like, the smartphone has been around 15 years. We all know it does something to our minds. We intuitively know this, but even now, after 15 years in research, it's very unclear, it's very controversial what it really does to human mental functioning and how bad it really is. Because these effects are hard to measure, they're very subtle, they might be different from one individual to the next. And those kind of unclear negative mental effects are to be expected with this kind of technology as well. Now, the third part, of course, just suppose you would have access to the electric stimulation of somebody else's brain. Evidently there's all kinds of manipulation and illicit behavior kind of things there. It's so evident, I also don't really want to go there. But I do want to mention a little bit the privacy and data protection aspect, because I thought this might be perhaps of most interest to you. So the main kind of, or one of the main kind of attacks, or perhaps business models, depending on your perspective, will work like this. If you can measure the brain reaction to stimuli, so let's say what somebody is seeing or what somebody is hearing, you can at least sometimes infer kind of interesting information from this. For instance, whether a stimulus is new or whether the person likes it or not. Depends a lot on the kind of signals you have, but very simplified speaking. So this is already an idea behind neuromarketing, which you may have heard of. So the big TV commercials, let's say the Super Bowl thing, they are always screened to consumers before, and they measure the brain reaction to the commercial, and then they can change the commercial a little bit to have more kind of reaction to this. So this is neuromarketing. This is also not new. This has been going on for at least 15 years. But now with these BCI implants, of course, you can do this on an individualized basis, yeah? Right? You can have constantly measuring this. Let's say you have a gaming environment and you constantly measure the brain signal as the one who is offering this. You can have like an individualized constant neuromarketing kind of thing. And I would suppose this would be one of the business models that the industry would go for. Also, from the signals you can perhaps infer other information, and there has been the first side channel attack on the human brain with these kind of technologies in the literature already 10 years ago. So what they managed to do was they managed to extract the PIN code of the person by showing them numbers. So this was quite spectacular, even though it was under quite unrealistic circumstances. But it works in principle, and I'm sure an audience like this, you will find many creative ways to get a lot of information out of this kind of data stream. So this is definitely one of the very evident kind of things that will happen. Okay, so what to do about it? So many people are concerned about these new technologies, and in the recent years there was some lobbyism, so to speak, or some campaigning, especially in the US, and the argument is, oh, these new technologies are so novel, we need new human rights. This was especially proposed by an initiative in the US, the so-called Neuro Rights Initiative. And they were quite successful. So, for instance, they got Chile to amend their constitution. In the Chilean constitution now there's an explicit protection of cerebral, so neural data. There is also a provision on mental integrity that's quite successful, and they also had quite a lot of resonance with the international media, so quite a lot of press coverage, which is still going on. So they were quite successful from this side of the things. Now, while I, of course, share their goal of protecting civil rights for the human mind, I'm also one of their, perhaps, most visible critics because of some problems I have with the way they are approaching this. So especially, I think the narrative that they are pushing, oh, our rights are so deficient and we need novel rights, has an unintended side effect that should it happen that we do not get novel rights, which is politically very unlikely, then this is kind of like a narrative that cuts and undermines and weakens the established protection. So I would therefore like to propose a more promising alternative, and that is working with the rights that we already have. And there's particularly one which I would like to mention to this audience, and that is the right to freedom of thought. So that is a very nice human right because you all already possess it. It is in the Universal Declaration of Human Rights, and it's in many other of these international instruments, and it is there. We have it. The problem with it is that although it exists for over 75 years, it hasn't really been applied by courts yet. So nobody really knows what it really means. It's not particularly clear what it means. And so the challenge of the day is to render this right and this idea more precise and to apply it to these kind of new challenges. And this is what I've been doing like academically most of the time in the last years. And if you look into the history why we have this right, the idea that the drafters of the Universal Declaration had was when they were thinking after the Second World War, what are the kind of things that we should protect the person against? Of course, we should have free speech and they need, food and shelter. But they said there should also be one other aspect. We should protect the human mind. And, with all these totalitarian ideological problems, these kind of things. So they had this idea, but they didn't really spell it out. You find this idea in the documents, but they don't elaborate on this much more. And they also said this kind of protection should be a special protection. So unlike ordinary human rights, they can always be balanced against other interests. So you all know this, you have the right to privacy, but still there could be governmental interest in security that will kind of override the right to privacy. So the drafters said, but with freedom of thought, when it's only about the internal side of the mind, that this should not be balanced away. So this is an unconditional guarantee. So this is a very strong right. It's one of the strongest human rights that there are. So we have this right, which very roughly means important parts of the human mind should be in principle out of reach of governments, and governments should protect individuals against the mind being interfered by others. This is very roughly what this right means, or you can say no unauthorized reading of or writing into the brain. So this right already is there, and the challenge is to get courts to apply this and to get countries to acknowledge this. And there are some promising signs. So the UN has just put out a report, and they were basically affirming this narrative. That's not an official UN position, but they're think tanks. So there's an emerging theme going on that this is how these kind of things should be dealt with. But this is, of course, an abstract idea that then would needs to be specified much more clearly. But getting this abstract recognition of this is, so to speak, the challenge of the day. And now finally, I have to get to an end. Now, many of these problems are not human rights issues, so the public debate is a little bit off point, but because human rights only come into play if you do something against the will of the person. Now, here, many consumers will probably want these kind of devices, so then that's not a human rights problem. The real problem is what should be the regulations, so what are the conditions for companies to put these kind of things on the market? And that this is the problem has been understood by international agencies, and at this very moment the countries are starting to negotiate whether we find common global rules for regulating this. This is done at UNESCO, and it's going on right now and in the coming weeks, so this is something to watch out for in 2025. And the draft is actually already out, and it does cover many of these things, data protection and so on, cybersecurity. It also affirms freedom of thought, so there's a lot of good stuff in there. However, it does not really get to the point of this consumer neurotechnology. And the reason for this is very simple. BCI is a technology right in the international tech race on AI. Many want to use the BCI data to train the AI, and there's a global competition. You see here the patents is basically US versus China, and China has said earlier in this year they would want this technology to be developed for non-medical purposes, for augmentation, these kind of things, but very strictly regulated. The EU has kind of like a more stricter position, but undecided. And the US, of course, at this moment does not want to regulate this very strongly at all. For them, at the moment, it's just a consumer product. So if we would want to have robust international regulations, these kind of things would need to come together, and under a new Trump 2 administration with Elon Musk being some kind of an influential figure, let's say this does not look all too promising. Okay, so much. This is something to watch out for. This is ongoing. Let me come to my conclusions. So BCIs for medical and consumer purposes are here, and if the risks are manageable, implantable BCIs will likely come. The course seems set. The question is only whether users will take it up. And now if I have the chance to have all of you in this room, and I'm so much out of time and I don't have time for Q&A, but let me now take a vote. Let's have a vote. You have three options, guys. Would you want to take this kind of a device if it comes from Neuralink? Would you be seriously interested in getting this if you can use your computer, let's say, twice as fast as you can today? That's option one. Second option, would you be seriously interested in getting this if this would be open source and somehow the CCC would do some data security audit? And the third option is, no way, I don't want to do anything of this. Okay, so please, I would really ask you to vote with me. So who would go for A? We have some brave people over there. You are the pioneers. Thank you very much. So who would go for B? Yeah, that's quite a lot. It's good. You're also the experiential guys. And who would be C? Okay, the last majority. Okay, thank you very much.